smallest Arduino Uno, really tiny thing about the size of the thumbnail, as well as a new one called the IMU Bluetooth Low Energy. Kind of a long name, but it adds inertial measurement, which is really nice. And it's the only Arduino with a barometer. So it has an accelerometer, gyroscope, and magnetometer. So that's who we are. I'm available. Feel free to contact me if you have any questions. I am going to try and bust through this talk and in hopes of getting as much out as I can. I would like you to hold your questions. I have a URL here if you'd like to submit a question. Afterwards, I think we're going to go in and do a hangout with my lead engineer. So that should be hopefully more helpful than the CEO answering questions. How many people here have used Arduino in the past? Good. So a good amount. Well, I won't talk too much about the basics of Arduino then. Today we're going to go over the basics of Bluetooth Low Energy really quickly. Then we're going to go into a Bluetooth Low Energy example with Arduino. So we have all of this stuff available on GitHub. Please feel free to download it and do what you like with it. These specifically use our chips. I assume that if you have the Adafruit product, you can use that as well with Arduino Leonardo. So let's see. I just really quickly want to talk about some of my favorite projects with Arduino. Granted, it's our product, so it's part of why it's my favorite. This is a project that MIT created. This is our product. It's a USB, so it's a really small Arduino. Perfect for, I guess, a handheld device. We also have one of the smallest tricopters flying around with a product inside of it, which is really cool to see that thing flying around. It's just so small. Let's see. All right, let's get started. So, Bluetooth Low Energy is quickly gaining traction everywhere. Many vendors are creating wearables and interconnected devices that use Bluetooth Low Energy for all kinds of things. Some of these things include, retail locations that use Bluetooth Low Energy proximity sensing to enhance the buyer experience. Others include smartwatch vendors who use Bluetooth Low Energy to transmit small amounts of data for feedback and fitness tracking. But what about the average hobbyist? The maker community is also adopting Bluetooth Low Energy at a fast pace, creating all kinds of Bluetooth Low Energy enabled devices, thanks to easy access to Bluetooth to the hardware itself. Sorry. How do I scroll down here? Sorry. Okay, good. So let's establish some of the things that we can do with Bluetooth Low Energy. It's also known as Bluetooth Smart, Bluetooth Low Energy, or BLE. So I'd like to cover what is a Bluetooth Low Energy master, what is a Bluetooth Low Energy slave, what is Bluetooth Low Energy and how does it work? So Bluetooth Low Energy is a subset of the Bluetooth 4.0 specification. It's been devised to advertise a small amount of data at any given time. The name of the game here is power efficiency, hence the low energy part of the name. This means that hardware will be very efficient, but you'll encounter a few changes that differentiate itself from Bluetooth Low Energy, or that differentiate Bluetooth Energy from Bluetooth 2.0. Unlike Bluetooth 2.0, BLE does not simply provide a serial interface for using AT commands. BLE works with profiles instead. A profile is simply a means to define a wireless communication between BLE devices. Bluetooth Low Energy chipset vendors usually have tools available that let you define your own BLE profiles and configure the BLE chip according to what you specify. One of the most commonly used profiles is the serial port protocol, which is intended to replace the serial cable between devices. Some of the most popular Bluetooth Low Energy chips come pre-configured with the profile, so you only need to know a few details about it without becoming too concerned about the configuration. One such vendor is Nordic Semiconductors, which makes the Nordic NRF 8001, which is relatively inexpensive. scrolls now. Their chip is easy to integrate into any hardware design. It comes with a custom Bluetooth LE UART profile already installed. The custom UART profile is simply defined as a service that can transmit and receive 20 bytes of data at any time, giving you something of a serial connection. It's a very, very small, but the amount of data that it allows, but nevertheless it's there. That chip, however, is simply a Bluetooth Low Energy slave chip, meaning it advertises itself and waits for something to connect to it, but it does not initiate a connection to a device. When you hear Bluetooth Low Energy slave, it helps you think of a fitness tracker or a smartwatch as such an example. BLE Master, on the other hand, is a device that can scan and initiate connections to BLE slave devices. You can think of a smartphone as a BLE Master device that scans for stuff and connects to it. So that's a very condensed version of how Bluetooth Low Energy works. Some of you may have noticed we left out more detailed points such as characteristic descriptors and GOT profiles. We don't need to cover that for the sake of getting started, but you should decide to explore BLE technology further. It's left up to you to report about it. So to build an example Android app that implements Bluetooth Low Energy functionality, we would need to make it work as follows. First, we need to scan for a Bluetooth Low Energy device for the advertisement. Our Android smartphone will play the role of master with an Arduino compatible IMU board as the BLE slave. Once the Bluetooth master detects an advertised slave device, Android app should be able to stop scanning after a few seconds to avoid draining the battery. Any detected BLE slave advertisements will provide the device's UUID, allowing the application developer a means to identify a particular BLE device. Once we've detected the device we want to connect to it and enumerate a few other things about it, the BLE slave profile will likely define a service UUID and associated characteristics that belong to the service. Each characteristic will have a UUID of its own as well. In our case, the BLE slave device, an Arduino, has a BLE UART service associated read and write characteristics. After cycling through characteristics and finding the read characteristic, we will need to bind an event handler by subscribing to the read characteristic. Whenever data comes into our master BLE device, our app will have the event handler fired off with a 20-character payload of incoming data. Keep in mind, sending and receiving data via the BLE UART service for this chipset involves converting a string value into ASCII character, or equivalent decimal values per character. Fortunately for us, there's an example Android app that we will develop that will address conversion of data corresponding to scenes. Our app should allow us to see incoming and outgoing data using a text area. We will want a text input to send data with a corresponding send button and a button to disconnect. Once you've gotten a grasp of this example, there's nothing stopping you. Sending and receiving data opens up the gateway to controlling your Arduino powered hardware with any commands you'd like. You can make anything from BLE controlled LED light shows to fitness tracking equipment to wireless 3D motion monitors. The world is your oyster. So let's get started with an example using Android and Arduino. So you should have the following. You're going to need the Java SE Development Kit, version 8, Android SDK, Node.js, and NPM, the Ionic framework, and the Arduino IDE. Since the majority of us already have the JDK installed, we can move on to the Android SDK setup. After downloading and installing the SDK on your machine, the APB command line tool should become available. Installing Android SDK should give us that. So the APB logcat command gives us real-time log output as we run our as we run our app on our Android device. Please note, this will require turning on developer options on your Android device under settings and making sure USB debugging is checked. I assume we've got that covered, so I'm going to skip that. So Node.js and NPM gets us Cordova and Ionic NPM package. Building our Android applications with Cordova lets us build everything from good old HTML and JavaScript. Lets us build it with HTML and JavaScript. The Ionic framework sits on top of Cordova and acts like an AngularJS framework, but for Android development. It even comes with a rich feature set of UI controls and icons right out of the box. The Ionic framework provides the Ionic command line tool, which is used to compile our HTML and JavaScript into an APK and load it onto our device. The Arduino IDE will provide us a set of tools for working with various Arduino boards, pretty much all of the Arduino boards. We can leverage the Arduino platform to interface our Android application with the real world, controlling lights, moving servo motors, and getting sensor feedback. After downloading, you may need to install the appropriate drivers for your Arduino, such as the Arduino Uno or Arduino Leonardo for Windows or Mac. Our board uses the latter. Our IMU board uses the latter, since it uses both the same chip and bootloader as the Leonardo. We provided sample sketches that can be loaded onto the Arduino board, so feel free to download them from our GitHub. Just there. So it's incredibly easy to establish a UART connection and receive data from a Bluetooth slave device. Since we're using Cordova to build our example app with HTML, we would only need to perform HTTP request to send the data back to our server. We can even render the data directly on our Android device using D3.js. My business partner is working on our slides right now. It looks like we originally planned to do a Wear example today, and then I fired up my Samsung watch today, and it didn't work. The charger is not charging. So we decided we were going to try and do a D3 example really fast, and it looks like he did not get around to it. But that being said, the Bluetooth Low Energy for us is really exciting. It's really starting to take off. The use cases are pretty broad, and Arduino, while it's a hobbyist platform, is great for prototyping your devices. Surely when you're done prototyping, you're going to probably not buy a whole bunch of Arduinos from us to make your actual product, but you can use our sample sketches. Everything's open source, so feel free to download our stuff and act with it. Our chip is available on fliparduino.com. So unfortunately, my talk is a little bit shorter than I thought it was going to be because of our Wear example. But if anybody has any questions, feel free to come up and see me afterwards. Also, like I said, we have a Hangout that we're going to start just to address some of these questions, which can be here. My business partner is very knowledgeable on this subject, so feel free to ask all the difficult questions, and we will take the time to answer them all. So thank you very much for your time today.